Yeah, hi, good evening, dear students. I'm going to explain probability 2 marks questions. This is a part 2. In the previous class, I have done part 1, around 9 questions. Today, I'm going to explain most important expected questions, around 10 questions. Yeah, good evening, Angela. I'm going to explain another 10 questions today. These are most expected questions, important questions only. I'm doing now. So yes, I will go through all the questions, then I will explain one after one. You can see now the questions what are given here. These are the questions that just I will show the questions. After that I will start to explain all the questions now. So these are the questions. See all the possible important problems. Just you can go through this. Sixth one related to leap year, non-leap year. Seventh one probability distribution. Eighth one related to system of equations. And ninth one using Bayes theorem. 10th one, this is a simple concept of problem, this one. Okay, these are the 10 problems I given, understood? So total 10 problems I am going to explain today. Yes, you can go through all the 10 problems. One after one I will explain now. Now the solutions. Excuse me. See the first problem. A card is drawn from a well-shuffled deck of 52 cards. Then find the probability of the red king card. The card should be red and also there should be a king. What is the probability to get a red king card? They are asking the red king card, what is the probability? Now you can see here, this is a more simple question. A card is drawn from a well-shuffled deck of 52 cards. Alright, they are given well-shuffled card, well-shuffled deck of 52 cards. Then find the probability of a red king card. So when they're talking here red king card, then you can see this problem here. What are the total outcomes of the card? 52 cards. So you can see number of sample points will be 52. Correct, that we can see a shuffled back of 52 cards. So n of s, if we consider, that will be 52. Number of sample points will be 52. Now you can think about you can consider the event n of is 52. So getting a red king card, suppose you can consider a is equal to the event. So event of getting a red king card, event of, I can consider event of getting a red king card. Red king card. So to total we have total out of 4 kings, we have 2 black and 2 red kings will be there. Correct, always you can remember. So what are the favorable events of n of a? Total king cards we have 4. In the 2 red and 2 black. So favorable events is n of a is equal to 2. Is it clear? Why? Because you will get 2 red, correct? 2 red and 2 black kings will be there. 2 black kings and 2 red king card will be there. So favorable to n of a is equal to 2. So now the required probability. So P of a equal to n of a by n of s. N of a by n of s. So we will get now 2 by 52. 1 by 26. So I have one doubt here. Suppose if they give, instead of red king card, if they give black king card, answer should be same. You will get the same thing because 2 black king cards and 2 red king cards. So 1 by 26 is the required probability. Now you can see another one. If A and B are 2 independent events, find the probability of occurrence of at least one of A and B. I hope you understood the first problem Anyone have doubt, let me know in the chat box. I can explain again. If you have doubt, please ask me in the chat box. I can repeat again and again. Now, coming to this one. So if A and B are two independent, they are given two independent events. Then find the probability of occurrence of at least one of A and B. When the given A and B are two independent events, what is meaning here? Since A comma B are two independent events, I can write P of, we can write here. Since A comma B are independent events, so they are given this one are independent events. I can say these are independent events. Since these are independent, I can write what is independent events. I can write when the events are independent. Now you can observe here. The given here the events are independent. The events are independent events. P of A intersection B equal to P of A into P of B. Since A comma B are independent events, P of A intersection B, probability of A intersection B is equal to P of A into P of B. Then probability of occurrence of at least one of A and B. When they are using at least one of A and B, the meaning is they are asking to find here P of A union B. I should find P of A union B. P of A union probability of, they are asking P of A union B, which is equal to, we know P of A union B, P of A plus P of B minus P of A intersection B. At least one of A and B means you should find union. P of A plus P of B minus P of A intersection B. I can get this one, P of A plus P of B. So I am going to simplify this. So I am going to simplify this one, P of B minus P of A intersection B. Can I write P of A into P of B, right? Because they are independent events. So here I can write P of M is 1 minus P of A dash. Plus I can take it P of B common. If you take P of B common, 1 minus P of A. What is 1 minus P of A? That will be complement. Correct. Here you can think about. When I have taken this one, I can write this value 1 minus P of A dash plus P of B into this will be P of A dash. Correct. So from these two, I can take P of A dash common. So which is equal to 1 minus. If I take P of A dash common, it is 1 minus P of B. Probability of B, again 1 minus P of B is nothing but P of B complement. So 1 minus P of A complement into P of B complement. So dash means complement. So here you can see, since A comma B are independent events, P of A intersection equal to P of A into P of B. P of, they are asking at least one of A and B means you should find union. P of A plus P of B minus P of A intersection B. Replace A intersection with P of A and P of B since independent events. Now P of M is 1 minus P of A complement plus P of B. Here I can take it P of B common from these two. You can take it from these two. I have taken P of B common. So P of B 1 minus P of A. Again 1 minus P of A is P of A complement, probability of A complement. Again from these two you take P of A complement common, 1 minus P of B. This is P of B complement. So P of A and B can be written as 1 minus P of A complement P of B complement when A and B are independent events. So like this we can do. Now the third problem. If two events, you can check that. Anyone have doubt, you can ask me again. Should I explain the second one? Is it clear? I understood the second one. Is it clear? Let me know. Is it clear about the second one? Should I explain third one? I hope is it clear. Should I explain third one? Then fine. I can explain. Yeah, good. Now third one. You see third one. If two events A and B are such that P of A complement is equal to 0.3 is given. P of A complement is 0.3. Can you think immediately P of A? Because P of A means 1 minus P of A complement. 1 minus P of A complement. So we'll get 1 minus 0.3. It will be 0.7. Right? The value will be 0.7. So this is P of A complement. Similarly, you can see P of B is given. So probability of B is given. You can check here. They are given this. Probability of B is given 0.4. So similarly, I can find probability of B complement will be 1 minus 0.4. It will be 0.6. I can find this 0.6, right? So easily you can find that is a 0.6. So that they are given P of A intersection B complement is given. So that is 0.5. See here they are given this one. This also is given. You can check that P of A intersection B complement. That means which is nothing but, you know that P of A into B complement is nothing but P of, I can write this one, A intersection B complement P of A minus B. P of A minus, we can write P of A minus P of A intersection B. I am trying to find P of A intersection B. From this you can think about, we know this value. What is P of A intersection B equal to 0.5? So from this I can write, here I can write from this 0.5, which is equal to P of A. P of A we know that P of A is, we know, 0.7 minus P of A intersection B. This will P of A intersection B. A intersection B from this equation. So I can find here this value P of A intersection B equal to P of A intersection B equal to, correct, I can write here. You can think this value P of A intersection B is equal to 0.7, 0.8, it will be 0.2. We got this. So now they are asking P of, you can see the result, they are asking P of B by A union condition for A union B complement. When I take it like this, you can observe here probability of, I can write B by A union B complement. They are asking this, right? A union B complement. When they are asking P of A union B complement, A union B complement. So they are asking this one, this I can write. Now you can check what about this one. So probability of B intersection A union B complement, A union B complement by P of A union, because they are asking, right, P of B by A union B complement they are asking. I can find this one P of A union B complement, right? We can do like this. Now you can check here, when I am solving this problem here, P of B intersection, if I expand this, P of B intersection A union P of, you will get this one, P of B intersection A, it comes here, P of B intersection A, you can check here, B intersection A union B intersection B complement, union B intersection B complement. So this is a probability of this by P of A union B complement. P of A union B complement is P of A union B complement, that we can expand this denominator, P of A plus P of B complement probability. Just I can expand directly this one, right? P of A, P of B complement minus P of A intersection B complement. We know all the values. P of A intersection B complement. Here we know that B intersection B complement will be empty set. So when you are finding this one, I am doing third problem, that will be empty set. When this is got empty set, we know that here. So this one B intersection B complement empty set. So this is empty set. Since this is empty set, this will become P of B intersection A by, we know P of A. P of A we got 0.7, right? 0.7. P of B complement 0.6. P of B complement 0.6 minus P of A intersection B complement is given 0.5. And P of A intersection B also they are given, right? In the given problem you can see that what is P of A. Next step I can write that P of A intersection B. P of B we got this one. Where we got P of A and we have done this. P of A intersection equal 0.2 we got this. Now I can write this 0.2. I can simplify now. The final step I can write. Now I can write P which is equal to 0.2 pi 0.7 plus 0.6 1.3 minus 0.5 0.8. So 2 by 8 1 by 4. That will be a required answer. 1 by 4. Model is important. Think what I have done here. Just you can observe here. The problem this one. See here. The given P of A complement is given P of A. 1 minus P of A complement. You will get P of A 0.7. P of B is given P of B complement 0.6. A intersection B complement is another P of A minus B. P of A minus B means P of A minus P of A intersection B. Now you can use this equation. You find P of A intersection B. That will be 0.2. When they are asking conditional property of P of B, given that A union B complement. So P of B intersection A union B complement by P of A union B complement. You expand B intersection A union B intersection B complement. But B into B complement is empty set. Then this will become P of B intersection A by you expand P of A plus P of B complement minus P of A intersection B complement. Substitute the values. Then we get 2 by 8. That will be 1 by 4. I hope you understood this. It's clear. Third problem. I hope you understood this. Anyone have doubt up to third problem, problem number 3? You can ask me. Is it clear up to problem number 3? I think, can I do the next problem, fourth problem? I hope you understood. Yeah, if you want I can explain the next one. Then fine, good. I can go to the next problem now. See the next problem. Let X denote the number of hours you study on a Sunday. Also, it is known that P of X equal to X given 0.2 when X equal to 0, Kx when X equal to 1 or 2, K into 4 minus X when X equal to 3 or 4, 0 otherwise. Then where K is constant, what is the probability that you study at least 2 hours? So they are asking at least 2 hours. So we can make given information, we can use the given information, we prepare one table, probability distribution table. Then that will be easy to solve the problem. What I will do now, the given P of X equal to 0, then I can write this is X, P of X, probability of X, I can write. Suppose 0, I can give 1, 2, 3, 4. What is the probability of P of X when X equal to 0? When X equal to that will be 0.2. See this I can write 0.2. When X is equal to 1, K into 1 K. When X is equal to 2, 2K. Correct, this is 2K. So just you can observe here, this is 2K. How sir? When X equal to 1 means 1 into K, 2 means 2 into K. When X equal to 3, 4 minus 3, again it will be K. When X equal to 4, 4 minus 4, that will be 0. Even though more than 4, otherwise that will be 0. So this is the table we can observe here. This is the probability distribution table. Correct, we can make it. This is the table to understand. Just I am doing, this is the table. I can draw this right. This is a probability distribution table. So I can make it like this. Just to understand this. You make it the table here. Then what they're asking here. So first you should find the k value. After that they're asking what is the probability that you study at least 2 hours. How to find k value? We know sigma p of x always equal to 1. In a given particular experiment, sum of the probability should be 1. Sigma p of x is equal to 1. I can make it here. Sigma p of x is equal to 1. So this one, sigma p of x is equal to 1. The total probabilities can add 0.2 plus k plus 2k plus k plus 0. Sum of the equal to 0. This is equal to 1. Now you can simplify. This will be 4k equal to 1 minus 0.2. 4k equal to 1 minus 0.2. This will be 0.8. K is equal to 0.2. Okay, k value 0.2. Now they are asking the probability that you study at least 2 hours. They are asking you study at least 2 hours. That means at least 2 hours means the probability of at least 2 means p of x greater than or equal to 2. At least means greater than or equal to 2. So I can find p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4. Well, otherwise that will be 0, right? P of x equal to 4. 2, 3, 4 I can consider. Substitute these values. So what is p probability of x equal to 2? X equal to 2, probability of x equal to 2 means it will be 2k. And 3 means k. And x equal to 4 means 0. It will be 3k. But we know that 3 into 0.2, it will be 0.6. That will be our answer, 0.6. So that is the required one. I hope you understood this. This problem will be easy, but expected question they may ask should be familiar with this. I hope you understood this. You find some of the probabilities. First you make the distribution table, find the sum of the probabilities. Since sum of the probabilities is equal to 1, find k value. Since at least 2 hours means x greater than or equal to 2, x equal to 2, p of x equal to 3 plus p of x equal to 4, substitute the values, then 3 into 0.2, 0.6. I hope you understood this. Anything if you have doubt, let me ask me, I can discuss again. If you have doubt, is it clear that one? Question number 4, is it clear? Question number 4, is it clear? Fine. If it is clear, question number 4, then can I do 5th one now? I'm going to do the 5th problem now. Yes, yeah. Fine, it's clear. Then I'm going to the 5th one now. Yes, fine. See the 5th one. The probability distribution of x is this. They are given probability distribution. They are asking find p of x less than or equal to 1. For you can practice this. Think again, sum of the probabilities is equal to 1. I can write sigma p of x equal to x is equal to 1. You can find sum of the probabilities. I can write k plus 2k plus 4k plus 2k plus k is equal to 1. You can add here 3, 7, 9, 10k is equal to 1. You will get 10k is equal to 1. K is equal to 1 by 10. It becomes 1 by 10, 0.1, 1 by 10. They are asking p of x less than or equal to 1. P of x less than or equal to 1. They are given x less than or equal to 1. Sometimes they may give at most 1. P of x less than or equal to is nothing but at most 1 means same thing. At most 1 is maximum 1. So this I can write. So these two I can write p of x equal to 0, probability of x equal to 0 plus probability of x equal to 1. But we know p of x equal to 0 is k. And we know that probability of x equal to 1 is 2k. 2k. So total we have 3k. So we know k is 1 by 10. So your answer is 3 by 10. Even if you want, you can write it 0.3. So this will be Your fifth problem similar to the fourth one. The model is important for 2 marks questions. They may give this. If we learn these questions, after that we can do case study questions, case-based study questions also. Then we'll be perfect in probability. I hope you understood this. Fifth one I understood. I hope you understood this. Should I do the sixth one now? Yeah. I hope it's clear. Can you do the sixth one now? We complete the fifth one. Should I do sixth one? Yeah. I think is it clear? Angela, Tanish, Karshit. I think I can do. I will repeat, Tanish. Just 1 minute. I will repeat this problem. Okay. See that in fifth problem, sum of the probabilities, they are given the table. Sum of the probabilities means add all the probabilities, values of probabilities is equal to 1. 10k is equal to 1, k equal to 1 by 10. Now they are asking only find p of x less than or equal to 1. That means left of 1. The 1 or left of 1. 1 or left of 1, 0 and 1. So p of x equal to 0 plus p of x equal to 1. Then p of x equal to 0 is k. P of x equal to 1 is 2k. K plus 2k, 3k. So 3 by 10, 0.3. Now, I hope you understood this. I am going to explain the sixth one now. Right, sixth one. See that now the problem, I will explain the sixth one now. Sixth also most important model, you can see that. Sixth one. Yeah. See the sixth one. In the sixth one, what is the probability that a non-leap year has 53 Tuesday days, a leap year has 53 Wednesday days, a leap year has 53 Fridays and 53 Saturdays? The concept of this is most important one. To learn this problem, the concept of most important one, this one, just you can observe here. So if you are observing this one, they will think non-leap year. What is the meaning of non-leap year and leap year? So the first one you can think about non-leap year. When they are talking about non-leap year, how many days should it be? Non-leap year 365 days. Non-leap year having 365 days. Leap year 366 days. Non-leap year 365 days. So what is the 365 days? We can split this. 365 days means I can also write 365 days. How many weeks will be there? 52 weeks. I can write 7 into 52 weeks plus 1 day. 52 weeks will be there. 1 day will be there. So 365 is nothing but 7 into 52 plus 1. That means 52 weeks will be there. I have written 7 into 52. So this is 52 weeks. Correct, 52 weeks plus 1 day. That means they are asking the first one. I am talking about non-leap year first. So leap year means you will get 366 days, 7 into 52 plus 2 days. So when I am solving the first problem, non-leap year, coming to solving the first problem, non-leap year. See, non-leap year, we have, this is the thing, 1 day. They are expecting 53 Tuesday days, but we have 52 weeks. So 52 weeks contain 52 Tuesday days, we know that. We can think about 52 weeks. 52 weeks, definitely 52 weeks, correct, 52 weeks, we can think contain 52 Tuesday days, right? 52 weeks contain 52 Tuesday days, right? I can consider 52 Tuesday days. Is it clear? I can consider 52 Tuesday days, right? So always you can think about this one, 52, it comes to Tuesday days. 52 Tuesdays it will be there. That means they are expecting 53 Tuesday days. The remaining 1 day should be Tuesday. The remaining 1 day should be Tuesday. Correct, the remaining 1 day should be Tuesday. Now you can see here, what are the favorable cases? This only one favorable cases. Correct, what is the probability? A non-leap year. Probability for 53 Tuesday days. So you can think about probability for 53 Tuesday days. 53 Tuesdays will be correct. They're talking 53 Tuesdays. So we have 7 days. Why? Because this remaining one day, maybe what is the possible one day? It may be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? These are possible we have. Correct. This will be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. This is the favorable cases 7. But we are expecting this favorable to 53 Tuesdays miss. So the favorable cases will be only 1. So probability of 53 Tuesdays is equal to 1 by 7. You will get 1 by 7. Coming to a leap year. See the next one, they are talking about leap year. In leap year, what is the meaning of when you are solving leap year problem here? See here, then talking leap year. So what is the leap, when if we take leap year, it will be 366 days. How many weeks again? 7 into 52 plus 2 days. Correct, 7 into 52 plus 2 days. This will be there. 52 again, 52 weeks will be there. Again, they are talking leap year has 53 Wednesdays. So they are talking 53 Wednesdays. That means we know that here already 52 weeks plus 2 days. 52 weeks contain 52 Wednesdays. That we know that 52 weeks I can write contain 52 weeks contain. You can see that I can write this one. Yeah, you can think about this one. Total 52 weeks contain 52 Wednesdays. Correct, 52 Wednesdays we will get. Now we want 53 means, so one day the combination of 2 days. So what about 2 days, the remaining 2 days possible? What are the favorable, what are the cases, what are the 2 days possible? Think about the 2 days, maybe the combination of 2 days, the remaining 2 days. When they are talking 2 days, the combination of 2 days will be, see the combination of 2 days, this will be, I can write Monday, Tuesday. This is a combination Monday, Tuesday. Otherwise it will come Tuesday, Wednesday, right? Otherwise it will come Wednesday, Thursday. Otherwise it will come Thursday, Friday. Otherwise it will come Sunday, you can see Friday, Saturday. Friday, Saturday. Friday, Saturday. Again this is possible. Saturday, Sunday. So you can see 1, 2, 3, 4, 5. You will get 3, 4, 5, 6. No, you will get Monday, Tuesday, Wednesday, Thursday. You will get Friday, Saturday, Sunday. Again Sunday, Monday. Sunday, Monday. Total 7. These are the 7 outcomes for 2 days. This is the combination. Monday, Tuesday, or Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, or Sunday, Monday. Total 7 possibilities. But we are expecting in a leap year, we are expecting 53 Wednesdays, right? 53 Wednesdays. So 53 Wednesdays means we want the favorable condition. So you can say how many are there here also Wednesday. So I can check here. This combination I will get here Wednesday. This is one combination. This is another combination. We have 2 combinations. So what is the probability it comes now? Favorable. 2 combination favorable. So probably in a leap year, probability of 53 Wednesdays equal to, in a leap year, probability of 53. I can consider probability of 53. They are asking 53 Wednesdays equal to, I can write 53 Wednesday equal to favorable because 2 by 7. 2 by 7. That will be your answer, right? 2 by 7. Correct. Only simple one, 2 by 7. Now we can think about next problem, the last problem. Again, in a leap year they are asking, we'll see the third problem. In a leap year, the leap year has 53 Fridays and 53 Saturdays. I want combination of Friday and Saturday. Similarly, you can know that they are asking 53 Fridays and 53 Saturdays. But we know 52 weeks contain 52 Wednesdays, like that. 52 weeks contain 52 Fridays and 52 Saturdays. So that one day combination will be Friday and Saturday. So Friday and Saturday combination we have only one day, you can see here. Friday and Saturday combination we have only one. So that means the probability of this favorable event is only 1. So 1 by 7. We can write that. All like that favorable events, right? So probability of the same thing, leap year case, I can consider. So the probability of, so third problem, the probability in leap year, probability of, they are asking 53 Fridays and Saturdays. 53 Fridays and Saturdays they are asking to see the probability of 53 Fridays and Saturdays. 53 Fridays and 53 Saturdays, right? Can think about just probability of this, we can write 53 Fridays and 53. So you can think about this one, 53 Fridays and 53 Saturdays. Then you will get 53 Saturday, the possible 53 Saturdays means this will be favorable only one case, this Friday and Saturday, so 1 by 7. So that will be our answer, 1 by 7. In a leap year, 53 Fridays and 53 Saturdays we get 1 by 7. So like that the simple way can do, but model is important. This model is most important. Anyone have doubt in this problem? Should I explain question number 6? Is it clear question number 6? Understood question number 6, is it clear? Should I repeat that question number 6? Is it clear question number 6? I understood question number 6. Yeah, anyone of you? Should I repeat that? Is it clear? Can I go to another question now? It's clear. Then we do other one now. Right. Then you see this another problem now. Seventh one, question number 7. If you look at the question number 7, again they are given, we should make it probability distribution table. We should find the required values. First, how to make it probability distribution table. Before we have done two problems similar to this. Now I am going to explain this. Let X denote the number of colleges where you will apply after your results, and P of X equal to X denote your probability of getting admissions in X number of colleges. It is given that P of X equal to X, given information. Now where K is positive constant, find K. That is first question. Also find the probability that you will get admission in exactly one college, at most two colleges, at least two colleges. You should familiar with at most and at least. Now see this problem. Problem is simple only. Should familiar the words at most and at least. First we make it probability distribution table. Then it will be easy to solve the problem. So what I will write now, the given X. When I take in X 0, 1, 2, 3, because more than 4 is 0 is given. Up to 4 I can consider. Why? Because more than 4 it will be 0. Then probability of X equal to X. When 0 here, you can consider when 0, that will be 0 I can consider. When it is 1, this will be K. Correct, it will be K. When it is 2, you can write K, X is equal to 2, it will be 4K. When it is 3 or 4, if it is 3, 5 minus 3, 2, it will be 2K. When it is 4, this will be K. Like you can substitute the values. Correct. Just you can observe here what I am doing. Just make the table. Look into the given information. We can make the table right. So 3 means 5 minus 3, 2k. We have the table. This is the table given. Because from the given information. But again we know sum of the probabilities is equal to 1. You find sum of the probability, I can write sigma p of x equal to x is equal to 1. This is sigma summation. The probability is equal to 1. You can see 0 plus, I can write 0 plus k plus 4k plus 2k plus k, which is equal to 1. Add all the probability. I am doing this one. 0 plus k plus 4k plus 2k plus k. Add all this. 2k. Add all the probabilities. So 5, 7, 8. 8k is equal to 1. K is equal to 1 by 8. We have k value 1 by 8. Leave it 1 by 8. Now what they are asking here? I got find k, we got 1 by 8. Now the first one, exactly one college. That means this x denotes number of colleges. One college means they are asking p of x equal to 1. This is the first problem now. They are asking what is p of x equal to 1. When they are asking p of x equal to 1, that will, what is p of x equal to, the probability is k. So the answer will be exactly 1 by 8. That will be k means 1 by 8. That will be our answer. At most 2 colleges. When they are talking at most 2 colleges, maximum 2. So you can think when they are asking at most 2, so be careful. At most means maximum to p of x less than or equal to 2. At most 2. So then what are possible x less than or equal to 2? I can write p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. P of x equal to 0 will be 0 we have, and this p of x equal to 1 k, and p of x equal to 2 4k. Total we have 5k, but we know k is 1 by 8. Your answer is 5 by 8. We got it. That will be answer 5 by 8, 5k. Remember, at most, then are using the word at most, x less than or equal to 2, maximum 2. Now you can see opposite, at least 2, at least minimum 2, at least 2, minimum 2 they are saying here. So you can see minimum 2 means, observe here, when they are saying minimum 2, the third problem, you can see here, when I am doing third problem now, minimum 2 means, so I am doing third one now, p of x greater than or equal to 2. This is me at least 2. So p of x equal to 2, p of x equal to 3 plus p of x equal to 4. Probability of this x equal to 3. P of x equal to 4. But we know that p of x equal to 2, 4k. P of x equal to 3, 2k. And p of x equal to 4, it will be k. Total we have 7k. But we know k is equal to 1 by 8. So we will get this is 7k. K equal to 1 by 8. 7k we have. This is 7k. Correct. Understood. This is 7k. We can write this one 7k. K value 1 by 8. So answer is 7 by 8. Like this. Remember, at most, at least important points. Remember, should not do the mistake there. I hope you understood this. Question number 7 is clear. Yeah, I hope you understood question number 7, I think. Can you do question number 8 now? I can do question number 8. Yeah. My dear students, yes, is clear. Then I can do question number 8. So do question number 8 now. The given different question, important model. Question number 8 is model is important. Just go through this question number 8. So when the question number 8, when they're talking this one, consider the system of equations ax plus by equal to 0, cx plus dy equal to 0, where a, b, c, d belongs to set of 0, 1. That means they are given two equations, system of equations. A, B, C, D values either 0 or 1 show that the probability that the system of equations has a unique solution is 3 by 8. So from the given information, what is the given system of equations we can write? This second given equations we have. So from this I can write, from the given equations I can write A is, because I can write given equations I can write, let A is equal to, in matrix form I can write, matrix I can write A, B, C, D I can write, and x equal to, I can write this one, because Ax equal to 0 matrix, x equal to xy I can write, x equal to xy, and this finally I can, this actually I can write Ax equal to 0 matrix, right? Homogeneous equations, right? I can write Ax equal to 0 matrix. A means this Ax is equal to 0 matrix, correct? From this one I can write this one, where A is this, x is this. We have taken like this. We can see, but the values of AP, we know that the values of A, B, C, D belongs to only 0, 1. That means A, B, C, D, either A can be either 0 or 1, B can be 0 or 1, C can be 0 or 1, D can be 0 or 1. Because each element two ways I can write. Two ways I can means what is the total number of, because number of matrices I can, matrix A can be chosen in how many ways I can choose. So number of matrices A, a number of, because how many A matrices will be there, I can choose here. Matrix A can be chosen, so you can remember matrix A. Matrix A can be chosen, correct? We can be chosen in, like each element 2 means like 2 into 2 into 2 into 2 power 4 ways, right? I can choose that way, right? Correct. So matrix A can be chosen in 2 power 4, correct? Matrix A can be, we can write chosen in 2 4 in 2 into 2 into 2 ways. Each element has two possibilities. That means we can write 2 into 2 16 ways, right? Which is nothing but 16 ways. So we get like matrices, different combination with this 1 and 0 will be 16 matrices you will get. 16 matrices. Correct. But they told here the system has unique solution. But this is homogeneous. When it has unique solution, the solution will be only, see, since the system has unique solution, if the given system has unique solution, then it will be x equal to 0, y equal to 0 only, the possibility. They given here, system has unique solution means the possible solution x equal to 0, y equal to 0. Y x equal to 0, y equal to 0, only it will be there if that A not equal to 0. When the system has unique solution, it's possible when x equal to 0, y equal to 0, only if that A not equal to 0. That is important here. I have written that A not equal to 0. I can write here x equal to 0, y equal to 0, only if that A not equal to 0. Because this is unique solution here. System is the given consists unique solution, homogeneous equations. Only x y equal to 0 only if that A not equal to 0. Now, in 16 matrices, because A can be chosen in 16 ways, in that what are the possible matrices, like the that A should not be 0. You can check that what is the that A should not be 0 means what are the favorable cases for A where that A not equal to 0. Check the possible cases. So since following this rule, we want that A not equal to 0. What are the favorable cases I can write? You can see matrix 1 0 0 1. This is one matrix I can consider. Another possible you can see here 0 1 1 0 I can write. So all the possible I am writing here. We can write 0 1 1 1. So you can check that 1 0 1 1. So you can see what are the possible I am writing here 1 0 1 1. So 0 1 1 I can write, and you can see all the possible it comes here 1 1 1 0, correct? So these are the possible places I have written. So all these cases that A not equal to 0. Satisfying that A not equal to 0 only we have 6 matrices, correct? But Then they're asking total we have 16 matrices in that data. In other, that means 6 doesn't have, says this 6 matrices should be non-singular, other 10 will be singular matrices. So you can see favorable to data not equal to 0 should be 6. The required probability I can write. The probability of system has a unique solution. They're selling unique solution. Probability of system is unique solution. Probability of unique solution. You can think, what about unique solution? When they're asking probability of unique solution, unique solution is equal to total 16 matrices to choose A. In that data not equal to 0 we have 6. So 6 by 16. So it will be 3 by 8. That is they are asking to prove. Simple one. If you think, you get easily. But most important one. Expected question this one. I hope you understood this. Is clear? Question number 8. Should I explain anything? You understood question number 8? Should I explain again question number 8? Is it clear? Eight is clear, I think. Can I do the question number 9 now? I can do question number 9. Right? Question number 9, I can go ahead, right? Fine now. I will do question number 9. So this is related to Bayes' theorem. Bag 1 contains 3 red and 4 black balls, while another bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Then show that probability that it was drawn from bag 2 is 35 by 68. So this is the given one here. This is using Bayes' theorem. They're talking bag 1 and bag 2. Drawing a red ball. Drawing a red ball from one of the bag, it is found to be red. The probability that it was drawn from bag 2. So we, again, first selection, you should select the bag. You can consider E1 choosing the bag 1. So you can write, I can write E1 choosing the bag 1, I can write. Suppose E1, so bag 1, to choose bag 1. E2, to choose bag 2, I can write. So to choose bag, I can write, correct, choosing the bag 1, bag 2. So I can consider here, so bag 1 and choose the bag 2. So automatically what is the probability of this? I can write P of E1 equal to P of E2 equal to off. Only we have 2 bags. You can select any one of the bag. So from this you will get right, implies this one I have written. E1 equal to bag 1, E2 equal to select, this is E2. I have written E2. E2 is equal to bag 2, P of E1 equal to P of E2 equal to 1 by 2. You can write this is E2 I have written here. P of E1 is 1 by 2. Even P of E2 also 1 by 2, right? Both are same, equal likely both you have. 1 by 2, 1 by 2 we got. Now you can see, drawing a red ball, getting this one, A be the event of drawing a red ball. You can consider A be the event of drawing a red ball. So you can think about this one, event of drawing a red ball. Event of drawing a red ball. First one, suppose if you are taking a red ball from bag 1, P of A by E1. You can think what is P of A by E1? P of A by 1. So you can see here, when you are talking P of A by E1, so what about this value? In bag E1 total we have 7 balls we have. In that 3 favorable to red balls is 3. So P of A by E1 is 3 by 7. Correct. We get 3 of 3 by 7. Right, you can see now is equal to 3 by 7. Is it clear? Because out of 7 balls, 3 favorable to red is 3. P of A by E2. Suppose red ball is from second bag. What is second bag? We have 5 and 5 red and 6 black. Total 11 we have. Favorable to red 5. 5 by 11 it comes. Next one. What they are asking? They are asking the ball what you have got from the bag. They are expecting the red ball should be, it was drawn from bag 2. So that means what you should find here? P of the ball, red ball should be bag due to P of E2 by A they are asking. By Bayes theorem, I can use by Bayes theorem this one. P of E2 by A. So by Bayes theorem, I can P of E2 by A equal to, I can write P of E2 into P of A by E2 by P of E1 into P of A by E1 total probability plus P of E2 into P of A by E2. This is the Bayes theorem. Use Bayes theorem, substitute the values, we get the required one. So Bayes theorem this one. So how can you decide? Because they are asking from bag 2, E2. That ball should be red. This is given. P of E2 by condition probability A is given. Then this is the Bayes theorem. Then I can substitute the values P of E2. We know P of E2 is 1 by 2. P of A by E2. P of A by E2 will be 5 by 11. P of E by 2 5 by 11. Substitute 5 by 11 by this P of E1 1 by 2 into this one 3 by 7 plus 1 by 2 into 5 by 11. Now you should simplify this. Take this one, numerator will be 5 by 20. You can write, you can simplify this. This will be 5 by 22. You can simplify this. 3 by 14 it comes. Or I can simplify, I can eliminate 1 by 2, I can take it common. I can eliminate that, I can simplify easily, right? Instead of doing this, what can I do now? I can just simplify, I can do like this. So you take 1 by 2, eliminate from this common, I can take it 1 by 2. So you will get this one, the final answer 5 by 11. By, we take 1 by 2 common, this is 3 by 7 plus 5 by 11. Now simplify, 77 LCM we can simplify here. It will come, we can simplify everything, correct? You can see that 11 it comes, 7 it comes here. You can simplify this 35 and this is 33 plus 35 68. This will come, then 11 will cancel, 35 by 68, 35 by 68 it comes. That will be the required answer. 35 by 68 they are given. Answer is going 35 by 68. You can simplify, that will be 35 by 68 Bayes theorem. There is a simple problem, but Bayes theorem concept is important. That is the reason I have covered Bayes theorem. Try to understand Bayes theorem concept. You solve similar questions 1 or 2 related to this. Then that will be easy to understand Bayes theorem concept. I hope it's clear. Should I repeat? Should I explain again? This is a clear. Question number 9 is a clear. If it is yes, the last question I am going to explain. I hope it is a clear. Question number 9. Should I discuss the last one? Should I repeat any question? It's clear. What about others who are attending? Tanish, is it clear? Yuvraj, is it clear? Okay, fine. Now you can see that the last problem, it takes only 2-3 minutes. I can complete this, the last one, then fine. So you see the last problem, a committee of 4 students is selected at random from a group consisting of 8 boys and 4 girls. Given that there is at least one girl on the committee calculate the probability that there are exactly 2 girls in the committee. They are asking that 2 girls are in the committee. So this is the given problem. A committee of 4 students selected at random from a group consisting of 8 boys and 4 girls. Given that there is at least 1 girl on the committee, calculate the probability that there are exactly 2 girls on the committee. See this problem. Concept is simple only. You can think. So here you can consider, let event A, at least 1 girl will be chosen. You can consider, to understand I can write event A, at least 1 girl, because this one, at least 1 girl on the committee. I can write this one, at least 1 girl. So they are talking at least 1 girl, you can write here, whenever at least 1 girl. So they are saying at least 1 girl will be chosen. That is A. So B will be the event exactly 2 girls will be chosen. This is at least 1 girl. What about the B, event B? So event B I can consider exactly 2 girls will be chosen. Exactly 2 girls will be chosen, right? Exactly 2 girls will be chosen. That is the event B. Now what they are asking here? Check observe here. Calculate the probability that there are exactly 2 girls on the committee. When at least 1 girl is given that means they are asking to find probability of B by A. That they are asking, right? You should find P of B by A. The meaning is P of B by A. They are asking P of B by A. P of B by A they are asking. So you should find P of B by A means you should find what is P of B by A. They are asking P of B by A. So what is P of B by A? P of A intersection B by P of A dash, P of A. Probability of A into probability of A. We should find P of A into P of A. To find probability of A, what I will do now? I will consider, we know that A is at least 1 girl will be chosen. A complement. What is A complement? If you take A complement, no girl is chosen, right? A complement means no girl is chosen, right? If I take this one, I can write no girl is chosen, right? If you consider this, the meaning is no girl is chosen. No, correct. No girl is chosen, right? So what is the property of A dash now? No girl is chosen means what meaning? I can select only the out of 8 boys, I can select any 4 boys. So what is the property of P of A dash? You can think now. P of A dash, I can write P of A dash equal to, what is the property of P of A dash? No girl is chosen means you should select only boys. So out of 8 boys you should select 4. 8C4. Total we have 12. 12C4. 8C4 by 12C4. You should simplify this. P of A complement. 8C4 by 12C4. You simplify these values. 8C4, 12C4. You can write this one, right? 8 into, I can write 7 into 6 into 5. 5, 6. Correct. By. I can write 4 into 3 into 2 into 1. By similarly I can write 12 into 11 into 10 into 9 by 4 into 3 into 2 into 1. 4 consecutive. Otherwise you can apply formula NCR equal to n factorial by r factorial n minus r factorial. That also you can use. NCR equal to n factorial by r factorial into n minus r factorial. This also you can use. Or you can do like this. Now you can simplify. I can simplify this. Everything you can simplify. Then you will get 7. You will get, if you simplify this 7, 6 2s and everything you can simplify here. What are the possible? You will get 14 by 99 it comes. You simplify. I have done directly, you can get here. 7 won't get cancelled here. So other term, this is 48, you can cancel this one. You will get this 99, 9 11s, 99. Because this will come. That 11 9 is 99. 7 2s, this 48 into 5. Like that I simplified. 14 by 99 it comes. This is P of A complement. Now automatically I can find P of A. What is P of A? 1 minus P of A dash. Probability of A dash. 1 minus 14 by 99. I can find, right? 1 minus 14 by 99. So it will come 19 14. 85 by 99. 85 by 99. It comes like this. Now you find P of A intersection B. What is P of A intersection B? 2 boys and 2 girls. I should find P of A intersection B. So 2 boys, the meaning is A means 2 boys and 2 girls are possible. The probability of, I can write 2 boys and 2 girls. Right, 2 boys and 2 girls I can consider. The meaning of this one is right. When you're talking about this one, 2 boys and 2 girls. 2 boys and you can write 2 girls. So what it comes when you're taking 2 boys means out of 8 1 2 boys 8C2 into we have 4 girls 4C2 any 2 by 12C4. Total 12 members, any 4 members. You simplify this. Same thing, you apply 8C2 and 4C 12C4. Everything you can simplify. Then you can see what the possibility comes. You will simplify this. So now, what is 8C2? I can write 8 into 7 by 2 into 1. 4C2, 4 into 3 by 2 into 1. Otherwise, I suggested use NCR formula. By 12C4, I can write 12 into, I can write this one, right? You can simplify this. Correct, 12 into, what is 12C4? 12C4, 12 again 12C, 12 into 11 into 10 into 9. Correct, this is a, I'm talking about 12C4, right? You will get this one, right? By 4 into 3 into 2 into 1. You should simplify this. If you simplify this, the final result, I remember this one, if you simplify, it comes 56 by 165. 56 by 165, you simplify. Everything you can calculate, I can save the time. You can calculate 56 by 165. Now we want P of B by A. So when I talk P of B by A, I know the values now. P of B by A. So this is required P of B by A equal to P of A intersection B by P of A. P of A and we know that 56 by 165 by P of A we have got it in the previous one. What is P of A value? P of A value is 85 by 99. P of A is 85 by 99. This is P of A 85 by 99. Then I can simplify 56 by 165 into 99 by 85. Now we can simplify this. Suppose I can eliminate this. Correct. We simplify this here. What a possible it comes now. Everything is simplified. You simply with the required value can write here. Right? Anyone got the simplification answer, final answer? Can you share me your answer after simplification? What do you get after simplification? 56 by 165 into 99 by 85. Anyone? Let me know answer, final answer. Reverse 11 table, right? Anyone got final answer? You simplify this. 11 nines it comes 11, correct? 11 15s. I can simplify this. Correct? Oh, even I can simplify. 3 5s, 3 3s. So you will get 168 by, correct? Multiply 5 85s. You will get 425. This will be your answer, right? 168 by 425. That will be the required answer. With this, I have completed all the problems. The calculation takes time. You should simplify all this. I hope you understood this. Should I repeat this? Is clear? Only takes calculation. Otherwise, problem will be easy only. Nothing is there in this. You can simplify. At least one girl will be chosen. Exactly two girls will be chosen B. There has P of B by A, condition probability, P of A intersection P of A. But I have taken to find probability of A complement. No girl is chosen. P of no girl means only boys. I should select 8C4 by 12C4. We got 14 by 99. P of A 1 minus P of A complement 85 by 99. P of A intersection B means common. So equal 2 boys and 2 girls I have taken, that is 56 by 165. P of B by A is P of A intersection P of A simplified. I got 168 by 425. With this I have completed today's session. The denominator is, I have written for 1 minute. I have taken 460, 425, the denominator, right? I have written 424 only, right? You can see the denominator, what I have written in the denominator? It will be 425. Yes, I have written. Yeah, that will be 425. Correct. Fine then. Good, then see you tomorrow then. See you tomorrow. Good night. Fine. If you like the session, you can like it. Your choice. If it is helpful, you can like the session. Yeah, just no unrock join. Yeah, okay, fine. If you understood, you can like the session.